Hi, in this video I will discuss question number 1 to 25 in your third term physics MCQ paper. Well, so let's start with the question number 1. Which one of the following has a different unit than the others? Pressure, kinetic energy per unit volume, potential energy per unit volume, friction, stress. Here, when you're reading the first three terms, your mind should automatically capture the Bernoulli principle, because we know in a fluid, the pressure, the kinetic energy per unit volume, and potential energy per unit volume, the sum of these three terms is a constant. So it won't take more than a second to figure it out. These three terms has same unit if you have a good practice in Bernoulli principle. Now we have only these two terms to consider. So if I consider the stress, we know stress is force over area, which is also has the same unit as pressure. And friction, it is a force, so it has a unit of force we know Newton, right? So the answer is friction, fourth one. Okay, let's move to the second question. What is the unit of permittivity? Actually, this is a very easy question. If you don't know the answer for this, means that you haven't practiced enough problems in electric field. Anyway, the answer is first one, and let's see how it comes. So if I consider the equation of Coulomb's law, I can write force is equal 1 over 4 5 epsilon times product of their charges divided by the separation between the charges. So from this equation, if I subject epsilon, I can write epsilon is equals q1 q2 over 4 5 f times r squared. Okay, so if I consider the now units, so I'm just going to just write in the units. So charge, we know coulomb times coulomb over 4 5, it's a unitless constant, and unit of force we know Newton times distance square means meter squared. So we get coulomb square per Newton per meter squared. So this is the unit of permittivity. In addition to that, the value of permittivity in free space, which is denoted as epsilon naught, has a value of 9 times 10 to power minus 12 coulomb square per Newton per meter squared. More accurately, we can write epsilon naught is equal 8.85 times 10 to power minus 12 coulomb square per Newton per meter squared. So in our advanced level syllabus, we use epsilon naught in free space, the value as this. Okay, and now let's move to the question number 3. Where is the center of gravity of this metal sheet? So for this, first I consider this rectangular part. So the center of gravity of this rectangular part is, we know, at point A. That comes from, if you draw two diagonals, where the diagonals intersect, there will be the center of gravity of this part, rectangular part. And similarly, if I consider this one, this remaining piece, this one also rectangular piece. So if you draw two diagonals, the center of gravity of this part will be at here. Okay, so if I draw a line joining this point and this point, okay, the center of gravity of this whole metal sheet is going to be at a point somewhere on this line. So now we have two choices, either E or D. Now we have to argue whether it's point E or point D. For this, I'm going to consider each square has mass simple m. So here we have in this part 10 squares, therefore mass of this part is 10m and this part is 2m. So if I consider the ratio of masses between this part and this part, so we get 10m to 2m, that means 5m to 1m, 5 to 1. So we can see the mass ratio is 5 to 1. Therefore, if I consider the ratio between distance to center of gravity to the whole sheet and the center of gravity from each part, the ratio will be 1 to 5. So here we can see point E is like 1 to 1 ratio. So only one possible value is point D, where it's like 1 to 5 ratio. So the answer is D. If someone doesn't understand how that ratio works, for example, let's consider that you hang this metal sheet vertically from its center of gravity. So we know center of gravity is point D. So now let's take the distance from A to D is simple A, and D to this point is simple B. And if I hang this from center of gravity, we know it will remain balanced. Okay, so I can take the torque, and the net torque is going to be 0. So from here, if I consider that, then I can write so mass of this part is 10 mg times distance to that point from center of gravity. Let's consider as A. So this is torque in this direction, and this is in the other direction. So and then we have here 2 mg times 2 mg times distance to that point I consider as B. The net torque must be 0. So from this I can write 10 mg times A is equal to mg times B. So if I take A divided by B, we get 1 over 5. mg cancels off, 2 over 10 means 1 over 5. So A to B is equal 1 to 5 ratio. And let's move to the next question. Consider the following statements regarding infrared waves. Statement A. Speed of infrared waves is less than 3 times 10 to the power 8 meter per second. Statement B. These waves consist of vibrating electric and magnetic fields. Statement C. A medium is required for these waves to propagate. Which of the above statement is true? Okay, so first thing we want to understand is infrared is a electromagnetic wave, right? So we know all the electromagnetic waves moves with a constant speed. That's the speed of light, and it is 3 into 10 to the power 8 meter per second. If you consider the radio waves or light, gamma waves or X-ray waves, all the electromagnetic waves moves with the same speed. That's this value, 3 into 10 to the power 8 meter per second. So statement A is false. These waves consist of vibrating electric and magnetic fields. As I told you, infrared waves is electromagnetic waves, so that's obvious. It consists of vibrating electric and magnetic fields. And the next one, a medium is required for these waves to propagate. We know electromagnetic waves can move in free space without any help of matter. So statement C also false. Only statement B is true. So the answer is second one. A car is moving in a circular path of radius simple r in a horizontal plane. The coefficient of friction between the car tire and the road is nu. If the tangential speed of the car is v, then okay. So this is a question. This question is about circular motion and friction. So let me draw a circle first. We know from our mechanics knowledge that a particle must be under a centripetal force in order to move in a circular path. And if I consider the road and the tires of the car, as you can see, these two are the back wheels and these two are the front wheels. And here R1, R2, R3, R4 are the reaction force acting on each tires, and F1, F2, F3, F4 are the friction force acting on each tires. So if I consider the net reaction force, that will be acting somewhere from here. So I mark that the net reaction force will be acting somewhere here, and let's say R, and that is equals to mg considering vertical force balance, and the net friction force, and that will be acting from here, from this same point in this direction. That's the net friction force acting on this car. So now if I mark draw the car in that path. So for example, if I consider that my car is here, okay, so the net reaction for friction force acting on the car is in this direction, that is F, toward the center of this motion. Okay, so this is the centripetal force acting on the car, so I can write the centripetal force F, that is equals to m v squared over the radius is simple r, so r. This is my equation 1. And we can see that there is no movement of the car in this direction. That means this car is under static friction in this direction. So under static friction, that so I can write F is equals to, sorry, F is less than or equals to nu r. Okay, so r is equal mg, therefore I can write F is less than or equal to nu mg. This is my equation 2. So from equation 1 and 2, okay, I can write, so F is equal to mv squared over simple r. So I can write m v squared over simple r is equals to nu mg. So here m cancels off, therefore I can write v squared is equals to m r g, therefore nu rg. So v is here less than or equal sign, okay, because F is less than or equal nu r under static friction, so we get v squared, so also less than nu rg, therefore v is less than or equal square root of nu rg. So the answer is third one. Okay, what is the escape velocity of Earth? We know the equation for escape velocity is given by v is equal to gm over r square root, capital G universal gravitational constant, m mass of the planet, and r radius of the planet. And we know since gm is equal gr squared, if I substitute instead of gr squared for gm, then I'll get v is equal to gr square root. You can find the value using this equation or else using this equation. So for me, I see this is very convenient and easy, so I'm using this one. So I can write 2 into where gravitational acceleration of Earth, that is 10 ms minus 2. It's provided in the front page of your paper. So 10 times the radius of the Earth, 6,400 kilometer. So 6,400, so kilometer we want to write it in meters, so 10 to the power 3 and the square root. So we get escape velocity taking square root, so here root 2 times square root of 64 is 8 times, now we have 10 to the power 3, 5, 6, 10 to the power 6 and the square root 10 to the power 3. So I can write root 2 is 1.41 roughly times 8 into 10 to the power 3. So we get v is equal roughly from this I get 11.3 10 to the power 3 means kilometer per second. So the answer is the fifth one. Okay, the question number 7. What is the quark composition of a proton? We know the nucleons, that means proton and neutrons are made of quarks. So if I consider the proton, so it consists of 2 up quarks and 1 down quark. So the answer is this. So similarly, the quark composition of a neutron is 1 up quark and 2 down quark. Okay, this is for neutron. Okay, and the next question 8. An astronomical telescope consists of two convex lenses of focal length 50 mm and 550 mm is used to view the moon under the normal adjustment. If the angle subtended by the final image of the moon on the eye is 5.5 degrees angle, what is the angle subtended by the moon on an unaided eye? Here the first thing you want to identify which one is objective lens and which one is eye lens. We know for telescopes the focal length of the objective lens is greater than focal length of the eye lens, and for microscopes the other way around. And if it seems difficult for you to recognize which one is for a telescope and which one is for microscope, think like this. We use microscope to see, view small things which is smaller than eye. So object is smaller than eye, like that. So here we use telescopes to view like moon, so its moons are larger than eye. So in that way it would be easy for you to recognize. Okay, so this is the ray diagram of a telescope under normal adjustment. We know under normal adjustment the final image should form at infinity. So if I consider light ray coming from the moon, okay, it refract from the objective lens and converge in the its focal point, because light ray coming from the moon is seems like coming from infinity, so it will converge at its focal point and therefore image will form here. So this image will be the object to the eye lens, and we have to adjust the eye lens such that this image should form at the focal point of the eye lens. So that in other words, this focal point of the objective lens and eye lens coincide each other. So when the object is at the focal point, it will the image will form at infinity. So angular magnification is beta over alpha, where beta is the angle subtended by the final image of the object and alpha is the angle subtended by the object on unaided eye. And also we can show that m is equal f naught over fe for telescope under normal adjustment using normal simple geometry. So from these two equations I can write f naught over fe is equals to beta over alpha. So f naught is 550 millimeter and fe is 50 millimeter. Beta 5.5 degree angle over alpha, what we have to find. So if I simplify this, we get alpha is equals to 0.5 degree angle. So the answer is third one. And the next question, what is the separation between the eyepiece and the objective in the above telescope? So from this we can see it's clear that the separation between the two lenses sum of the focal lengths. So I can write d is equal f naught plus fe. Okay, so you can write d is equal f naught is 550 millimeter plus 50 millimeter, so 600 millimeter, that means 60 centimeter. So answer is first one. Okay, these are basically theories. Okay, so very easy questions. Okay, so go through your notes and understand, and also try to derive this relationship using simple geometry. Okay, and the next question, what is the current supplied to the circuit by the battery? Well, this is also an easy question. Okay, so we want to find the current in the supplied to the circuit by the battery. So what we want to do is basically we want to find the equivalence resistor. So I can simplify this, so here these 1 2 3 4 5 6, these 6 are parallel. So if I simplify this, I will get, so each resistor is R, so 6 divided R divided by 6. Okay, and then we have here 2 resistor and this side 2 resistor, so these two we can see parallel. Okay, so if I take this R and R, so we get R divided by 2. Okay, and similarly here below also we get R divided by 2, and in between we have this resistor R. And again here R. Okay, and then here 3 parallel resistors, so we get here R divided by 3, and this end connected to the negative terminal of the battery, and this side is E. Okay, so if I see here, so we can see here this this resistor divided by this resistor is equal to this resistor divided by this resistor. This is in a Winston bridge, so we can remove the center resistor from the circuit. We can remove this resistor from the circuit, so we get these two series and these two series. So the equivalence of these two are half plus 1, we get 3 over 2R, and here we get 3 over 2R. So now these two are parallel, so we get parallel and equal resistors, 3 over 2R, 3 over 2R. So equivalence of these two we get. So I will simplify this circuit further. So I get, we have here R over 6, and then the equivalence between these two, that's going to be 3R over 4, and here we have R over 3. Okay, and let's say the current in the circuit is I. Okay, and battery E. So now equivalence of these three is the addition, so I can write the I, E equals I times addition of this R over 6 plus 3R over 4 plus R over 3. So E is equal I times, if we simplify this we get 15 R over 12. So from this we can write I is equal, sorry, here 12. So from this we can write I is equal 12 E over 15 R. So answer is fifth one. Okay, and the next question, question number 11. A Vernier caliper is calibrated at 20 Celsius and it has plus 0.2 mm zero error. This Vernier caliper is used to measure the external diameter of the test tube at 60 Celsius and the reading was 12.57 cm. The linear expansion coefficient of the metal of the Vernier scale is 1 times 10 to the power minus 4 per Kelvin. What is the actual diameter of the test tube? Okay, so far we did 10 previous questions, but there had actually nothing to think. But in this question, you have something to think. Okay, so let's see how can we solve this problem. Okay, so this is the cross section of the tube, and we want to measure this. We want to find the actual diameter of this tube. Okay, that means we want to find this length. Okay, and this is the scale at 20 Celsius and this is the scale at 60 Celsius. It says the scale has plus 0.2 mm zero error. So if I start to measure from here, okay, so this is a 0.2 mm error, this. Okay, and if the temperature increases to 60, what happens, this whole scale will expand, so including this 0.2 also expands. So here also the reading is 0.2. this one is 0.2 millimeter, because this one also expanded. Okay, so and it says the reading of the diameter is 12.57. The reading of the diameter is 12.57. so we can get this length at 20 Celsius. That is going to be you want to subtract 0.2 from this value, then it will be this length. I can say that is 12.55 centimeter. Okay, and at 20 Celsius the 12.55 centimeter scale reading will be somewhere here, right? 12.55 centimeter. And once the temperature increases, this part is 12.55. okay, here to here this length is 12.55, because this is 12.55. okay, excluding this 0.2 millimeter error. So this length somewhere here, that's going to be equal to 12.55, and once the temperature increases, this will expand up to here. Okay, so let's say this is the length we want to measure, that is, let's take it as L. That's the actual length we want to find. Okay, so how can we do this? So here now I can consider this length. Okay, and I can use this equation. L is equals L naught 1 plus alpha theta. Okay, I can use this equation. So I'm considering this length to be L naught, which is 12.55 centimeter at 20 Celsius. Okay, so I'm writing L is equal to L naught 12.55 centimeter times 1 plus alpha is 10 to power minus 4 times change in temperature is 640. Okay, the change in temperature is 40. So if I simplify this, I get L is equal 12.55 centimeter times, so 1 plus, so here this is 1 plus 0.004. so L is equal 12.55 centimeter times 1.004. so we get L is equal roughly 12.6002. so this is actually roughly, I can say L is equal 12.6 centimeter. Okay, so now we can see at 20 Celsius this is 12.55 centimeter. When we increase this temperature to 60, it expands this much, and that actual length is 12.6 centimeter. That means here this length is 12.60 centimeter. Okay, so not actually this reading, actually I mean this length L. Yeah, so this then this length is 12.60, therefore this diameter is actually 12.60 centimeter. So that's the answer, third one. A trolley of carrying bricks moves in a smooth horizontal surface. In every 5 seconds, a brick is released vertically downward from the trolley. At t equals 0, a brick is dropped. At that moment, the total mass of the trolley, including the bricks, is 25 kilogram, and its speed is 5 meter per second. What is the speed of the trolley after 28 seconds? Mass of a brick is 2.5 kilogram. So it says this trolley moves in a smooth horizontal surface. So in smooth surface, therefore no friction acting on the wheels of the trolley. Therefore we can consider no net external force acting on the trolley in horizontal direction, so we can consider the momentum conservation. So it's basically a momentum conservation principle. So I'll consider the trolley now. So here is the trolley, including the bricks. So these are wheels, smooth in horizontal surface. Okay, so let's say at t equals 0, this is, it says at t equals 0 a brick is dropped. Okay, and the total mass of the trolley including the bricks is it's 25 kilogram. So 25 kilogram, and the speed of the trolley is 5 meter per second. Okay, so we want to find the speed of the trolley after uh, 28 seconds. Okay, so what happens, so we know with the time in every 5 seconds a brick is dropped. So brick is dropped means the mass of the trolley including the bricks will be decreased. So mass decrease, if momentum is conserved, the speed has to be increased. Okay, so how can we find that? So we can use momentum conservation principle in the horizontal. So using, so I'm going to use this at t equals 0. I'm going to consider the total momentum at t equals 0 and at t equals 28 seconds. Okay, so at t equals 0 we can write momentum is 25 into 5. Okay, and the mass after 28 seconds. Okay, we know from every 5 second brick is dropped. Okay, so I can write the mass after 28 second is 25 minus, so we know after 5 seconds one brick is dropped, after 10 seconds the second drop brick is dropped, and the 15 seconds third is dropped, like that. In the 25th second fifth brick is dropped, so 5 times the mass of a brick is 2.5 kilogram. So this is the mass after 28 seconds. Okay, and the speed we don't know, we want to find, I'll take that as u or v. So I get subject v, I get v is equal 25 into 5, 25 times 5 over 25 minus 5 into 2.5 is 12.5. So we get v is equal 25 times 5 over 25 minus 12.5 means 12.5. So we can divide 25 and 12.5, right? There are two 12.5 means 25, so we get 2 into 5, so v is equal 10 ms minus 1. So this is the answer, I mean the fourth one. Then and then the next question, 13th one, what is the net electric field intensity at point O? So here okay, we want to find the total electric field intensity at this point. Okay, so now we can, if I consider this outer square. Okay, so there are minus q minus q minus q minus q charge in each corner. So if I consider the electric force due to these charges, it's going to be 0, because here if I keep plus 1 coulomb, it will attract in the same magnitude, this will attract, so the forces will cancel off. Similarly this one and this one cancels off, and here if I consider these four forces, four charges, so this one and this one cancels off, this will repels and this one also repels, so forces are equal in magnitude, opposite in direction, so net is 0, these two cancel off. But if I consider this one, so this will repels this side due to this charge, and this due to this charge here, if I keep a +1 coulomb, it will attract. So here we have electric field due to these two charges. So I can write the electric field intensity E is equals to take E1 due to this plus Q charge. So E1 is equal 1 over 4 5 epsilon Q over distance. So we want this distance, so this is square. Okay, so this distance a, this distance a, so this one will be root 2a, a squared plus a squared square root. Okay, so it comes a squared plus a squared square root of this value, that is equal root 2a. If the two sides are equal of a right angle, the hypotenuse is given by, for example, let's say AA, then it's going to be root 2a. You should be able to get this quickly. Okay, so I can write this is distance squared, so root 2a squared. This is E1, and I can now write electric field due to this one. That is, if I consider E2, that is 1 over 4 5 epsilon minus q over, here the distance also the root 2a squared. So the net electric field is, so both E1 and E2 acting in the same direction, so we can write net E is equals to E1 plus E2, and from these two you can see E1 is equal E2. Okay, so I can write E is equal 2 times twice the E1 value, so 2 into 1 over 4 5 epsilon q over root 2a squared is 2a squared, so here 2 cancels off, so we get 1 over 4 5 epsilon q over a squared. So the answer is first one. Okay. Okay, 14. Consider the following statements. Statement A: the resistivity of a semiconductor material increases with the temperature. B. Phosphorus atoms are called acceptors when they are doped into silicon crystal. C. In a p-type semiconductor, the hole concentration is larger than free electron concentration. Statement D. The net charge of an n-type semiconductor is negative. Which of the above statement is true? Okay, so first let's consider the statement A. The resistivity of semiconductor material increases with the temperature. Okay, so if I consider the conductivity of a semiconductor, so the conductivity of a semiconductor is based on actually the thermal agitation or thermal excitation, that means bond breaking due to absorbing heat. So what happens when the crystal bond absorbs heat from the surrounding, and then electrons excited and moves to conducting region. So if we increase the temperature, what happens, that process will be very easy for the electrons to bond the break and come to the uh, conduction. So actually the resistivity of a semiconductor material decreases with the temperature, right? So actually I can draw that. If I this is temperature axis, and this is resistivity rho. So with the temperature, what happens, it will decrease. So if I draw the conductivity of a semiconductor, conductivity sigma with temperature, so with increase in temperature, what happens, the conductivity resistivity decreases, means conductivity will increase, right? So the conductivity of the semiconductor material will increase like this. Okay, so the statement A is false. Okay, next one. Phosphorus atoms are called acceptors when they are doped into a silicon crystal. This statement is false because we know phosphorus is a group 5 element, so it has 5 valence electrons. That means 5 electrons it's in outer shell. So when we dope a phosphorus atom to a silicon crystal, 4 of the electrons in the phosphorus atom will make a bond with neighboring silicon atoms, but the remaining one, it will break their bond and moves to the conduction, I mean to the silicon crystal. So here what happens, so the phosphorus atoms will donate one electron to the conduction. So we say that phosphorus atom is a donors, okay, so not acceptors. So statement B is false. Okay, and the statement C, in a p-type semiconductor hole concentration is larger than free electron concentration. So if we consider a p-type semiconductor, for example, silicon crystal is doped with boron atoms. So we know boron atoms has only 3 electrons, okay, so each of these 3 electrons make bond with neighboring 4 silicon atoms and there are one vacancy or deficiency of electron. So what happens, so to complete the bond, so the boron atom will take electron from the conduction, I mean in the free electrons there were like free electrons due to thermal excitation. So one of those electrons come and fill that vacancy or deficiency and complete the bond. So what happens there, the boron atoms is accepting electron from the conduction, so we say that boron atoms are acceptors. And if you dope with more boron atoms, what happens, there are more uh, holes created, so we can say the hole concentration is larger than free electron concentration. So statement C is true. Okay, and the statement D, the net charge of an n-type semiconductor is negative. That's false. We know either it's n-type or p-type, the net charge is neutralized, I mean the net charge is 0. Okay, so the answer is only C, the second one. And question number 15. A train is moving in a straight track with half the speed of sound and it blows a whistle of frequency of naught which is placed in the front block of the train. The distance between the front block and the last block is 100 meter. If a seated passenger in the last block heard the whistle with frequency f, then okay, so actually this is a very easy question. Okay, so I'll take my train, I mean the picture of the train. So in this train we have 1 2 3 4 5 blocks, and in the front block we have the whistle and it's going with frequency f naught, right? And the passenger is in the last block, he is hearing the frequency heard by the passenger is f. So we want to find the relationship between f and f naught. So what is Doppler effect? The change in apparent frequency when there is a relative motion between the source and the observer. So can you say, is there a relative motion between the source and the observer? It doesn't matter how, whatever the distance is, whether the passenger is seated in this block or this block, or maybe climb on the top of the train, doesn't matter. If the relative speed is 0, okay, going to be here the same, right? Because no relative motion. So that's the definition, no, the apparent frequency is changed when there is a relative motion between the source and the observer. So here there is no relative motion, so the frequency heard by the observer is going to be the same. So actually this is a very easy question. Okay, so also I said that it's moving in a straight track. So the purpose of that is, so if I consider a straight track, then only the distance between these two remain the same. If for example, if the train is moving like this path, so the distance between source and the observer will change. Okay, so there will be a small relative motion to avoid that, I said that the train is moving in a straight track. Okay, so the apparent frequency is same as the source frequency. So the answer is fourth one. Okay, and let's move to the next question, 16. Here we have three arrangement of prisms. Okay, and the different rays coming through the prism. So okay, so we want to find which one gives an erect image of the coconut tree. Okay, so actually this is also very basically very easy question. So what I can do is, if I consider another ray coming from, let's say this ray is going from the the bottom. So if I consider another ray coming from the top of the uh, coconut tree, so I can mark that. I will draw in the same this one. So it will like this, right? Comes here and here. Okay, so here we can see the top is coming to the top. Okay, bottom is coming to the bottom, down. So we can see an erect image by the eye. So I can see an erect image. So A is okay, fine. And if you consider similarly, if you fill this, okay, so the ray coming from the top is will be like here, here, and okay, so it's incident with the same angle, so it will refract with the same angle, so it's parallel always. And again, and it comes to here, so tops comes to here, like, so it's like this is we don't get an erect image, it inverted. Similarly, if I consider here, this one will be comes like this, and this, and again comes to down, so this one also inverted. So the answer is A. Only A is only in A we can see an erect image of the coconut tree. Well, question number 17. This is a very easy question because you are very used with it. Okay, from yours it seems. Anyway, the displacement time of a particle is given as shown in the figure. What is the corresponding velocity time graph? So we can see here the displacement is increasing linearly. Okay, that means it has a constant speed. So 0 to 1 second it has constant speed, so from that we can neglect 1. Okay, and 1 to like 2.5 seconds we have negative gradient, that means negative velocity. So in this part the velocity is in the other direction. If in this part, if the velocity is one direction, in this part it has to be negative. So from that, so we can not fifth one as well, so either second, third, or fourth. Okay, and we can see the speed is constant from 1 to 2.5 seconds. So 1 to 2.5. Okay, this is fine and this is fine. It's not true for this, so we can expel third one. So either 2 or 4. Okay, so from this 2.5 to 3.5 second, its distance is the same, that means speed is 0. So 2 for both, agree with that. Then in this part here we have the gradient that is same as this gradient, no? Okay, this gradient and this gradient seems to be same. So here and here velocity should be same, so here and here same, but this one is not true. So the answer is fourth one. Well, let's move to the next question, 18th one. The absolute humidity of a room is 18 gram per meter cube, and the relative humidity is 50%. The volume of the room is 40 meter cube. What is the new relative humidity if 30% of the water vapor mass is removed from the room at constant temperature? Okay, so if you know the theory, this is also a normal question. Okay, so we take my room. Okay, this is my room. Which is 40 meter cube. Okay, and it says absolute humidity is 18 gram per meter cube. That means if I consider a 1 meter cube, there are 18 gram of water vapor. Okay, so this room is 40 meter cube. So in 40 meter cube, so the total water vapor mass is 18 gram into 40. Okay, water vapor mass. Okay, and it says the relative humidity is 50%. So RH equals 50%, and we know RH is relative humidity is equals to mass over saturated water vapor mass times 100%. So here this 50% is equal M. I can write 18. The mass of water vapor is this value, 18 gram into 40 over saturated vapor mass MS times 100%. So this yields saturated vapor mass is equals, so 51 2. So MS is equal 18 into 40 into 2 gram. So that means if the room is saturated, we have to have this much of water vapor mass. But 50, it's a relative humidity 50%. That means we have only half of this value, that is 18 into 40 grams. Okay, and then it says if 30% of water vapor mass is removed, so I can write the removed water vapor mass is 30% of the water vapor mass, 18 into 40 gram. So this is the removed water vapor mass. So the remaining water vapor mass I can get by total vapor mass, this value subtracted by this value. So I can simply here 18 into 40 minus this value. So this is the remaining water vapor mass. Okay, and if I divide this by saturated vapor mass, 18 times 40 times 2 and multiplication by 100%. So this is the water vapor mass, and this is saturated water vapor mass in a ratio times 100% is the relative humidity, right? Okay, so this gives the answer. So from this I can divide 18 into 4, 18 into 4, sorry, 18 into 40, yeah, in both numerator and denominator. So I get here, and multiplying this by 100, so I get 100 minus here 30, okay, over 200 minus here 100 cancel off 30 and yeah, percent is equal relative humidity. Therefore relative humidity is equal 100 minus 30, 70, 70 divided by 2, 35%. So answer is fifth one. Two spherical bodies A and B and the radius are given are at temperature T1 and T2 respectively. The maximum intensity in the emission spectrum of A is 500 nanometer and in that B is at 1500 nanometer. Considering them to be black bodies, what will be the ratio of the rate of total energy radiated by A to that of B? Okay, so if I consider the energy emitted by A is E1, so I can write E1 is equal E1 times A1 sigma T1 4, and if I consider this one energy emitted by B is E2, I can write E2 is equal E2 times A2 sigma T to the power 4. Okay, and it says considering them to be black bodies, therefore I can write E1 is equal, E2 is equal 1. Okay, emissivity is 1 because they are considered to be black bodies. So we want the ratio, so I can write the ratio E1 over E2. This is what we want to find, so I will get A1 over A2 times T1 power 4 and T2 power 4. Yeah, and sigma cancels off where it's a constant. We say that Stefan constant. Okay, so the area we can find, the radius is given. Okay, so from that we can find the areas of each bodies, and we want to find the temperature. It says that emission, the maximum intensity in the emission spectrum of A is at 500 nanometer. So from that we can write, that means T times, we know lambda max is constant. This is Wien's law. Okay, therefore I can write, from this I can write T is proportional to 1 over lambda. Okay, so I'll get here, I write E1 over E2 is equal, A1 is 4 5 r squared, r is 6 squared, so 6 squared over A2 4 5 times 18 squared. So here we get T1 over T2 power 4. Okay, so I can write this E1 over is equal 4 5 4 5 cancels off, so 6 squared over 18 squared is, I can write 3 squared. 18 is, we know, 3 into 6, so 3 squared times 6 squared. Okay, and from this t is inverse proportional to lambda, I get T1 over T2 is equal to lambda 2 over lambda 1 per 4. Okay, so I get E1 over E2 equals 6 squared, 6 squared cancels off, 1 over 3 squared times lambda 2 over lambda 1. So lambda 2 is wavelength of B. Okay, wavelength of B is 1500 nanometer, 1500 over the wavelength of A. That means the maximum wavelength of A, the wavelength which gives maximum emission. Okay, over power 4. Okay, so this is equals 1 over 3 square times 1500 divided by 503, so 3 to power 4. So we get E1 over E2 equals 1 over 3 squared. 3 to power 4 is, I can write 3 to power 2 times 3 to power 2, so these cancels off, so 3 to power 2, this one is 9. So answer is that one. Okay, so that's all. And yeah, go through the theories and notes. So if you know the theory, these are nothing actually. Okay, and let's go for the 20th question. A capacitor is made of three thin conducting plates A, B, and C as shown in the figure. The plates A and C are fixed, but plate B can move freely along the x-axis, and there are three statements. The capacitance of the capacitor is maximum when B is at x equals A over 2. The capacitance of this capacitor is minimum when B is either at x equals 0 or x equals A. The capacitance of this capacitor does not depend on the position of B. So we want to find the capacitance of this capacitor system with respect to the position of B. So I consider this distance is like x. Okay, this distance is, I consider x, and then I'm going to, so this is my C1 capacitor, C2 capacitor, and this whole capacitor C. So I can write down, since these are series, we know 1 over C is equal 1 over C1 plus 1 over C2, and C1 I can write C1 is equals to, if the cross section area is A epsilon naught over the separation is X, and C2 is I can write A epsilon naught over this distance, so this length is A, and if I this X, this is A minus X. So from this I can write C is equal C1 times C2 over C1 plus C2, and substitute in these values here. C1 is A epsilon naught over X times A epsilon naught over A minus X divided by C1 plus C2. So A epsilon naught over X plus A epsilon naught over A minus X. Okay, so we want to solve this, I mean simplify this, so I get C is equals to A epsilon naught times A epsilon naught over X times A minus X. Okay, and divided by, I taken common denominator, so that is X A minus X, and I can take A epsilon naught out from this term because those two are common. So here A epsilon naught, so if I take common denominator, here becomes A minus X plus X. Okay, and here now A epsilon naught times A epsilon naught over X A minus X. So division becomes multiplication when you take the reciprocal. So here we get X A minus X over this minus X cancels off, simple A times A epsilon naught. So here this one cancels off, so we can write C is equals to here X A minus X cancels off, so C is, finally we get A epsilon naught over A. So this is the capacitance of this one, the whole capacitor. Okay, and we can see that does not depend on X, I mean the position of B. So if you keep this X to be somewhere here, still you get the same value. If you take this to here or whatever the point, it doesn't matter, you still get the same value. So the capacitance of this capacitor does not depend on the position of B. So that's the true statement. Okay, so the two are false. So here they ask in the false statement, therefore false statements are A and B, so the answer is fourth one. Okay, and 21st question. What we have in 21st question? Okay, 1 kilogram of water at 0 Celsius is mixed with 3 kilogram of water at 100 Celsius. What is the final temperature of the mixture? So actually this is a very easy question. If you have good practice, you can find the answer without writing any equations and all. Anyway, I will do this. So we have 1 kilogram of water at 0 Celsius. So if we mix these two water, what happens? The cold water absorb heat from the hot water, right? So heat absorbed by the cold water, which is water at 0 Celsius, is equal to heat lost by the hot water. Okay, so I can write the heat lost by the cold water, that is M. So that is mass is 1 kilogram, 1 times C. For water we know 4200, right? In fact this value is not necessary. Okay, I will first write down in equation wise. So this say M cold, okay, cold water, C delta theta. Let's say temperature increase to theta from 0. is equal m hot C water again. Okay, and temperature decreased to theta from 100 minus theta. So the heat gained by cold water is equals to heat lost by hot water. So here C cancels off, so we get C is 1 kilogram, and here this one also, this is 3 kilograms. So 1 times theta minus 0 is equal 3 times 100 minus theta. So simplifying this, we get theta equals 3 times 100 minus 3 theta. So for theta equals 3 times 100, so theta is equal 304 times 100. We know 304 is 0.75. 0.75 into 100 means theta is equal 75 Celsius. So answer is the fourth one. So here the mass is 1 to 3 ratio. If the mass is 1 to 3 ratio, the temperature is 4 to 75. For example, if I mix 1 kilogram of water with 1 kilogram of 0 Celsius water and 1 kilogram of 100 Celsius water, so mass ratio 1 to 1, then we get temperature is 50 Celsius. Okay, or if I add 1 kilogram of this and 2 kilogram of this, then the mass ratio is 1 to 2, so we get 66.7. okay, there's a pattern. Okay, you can understand, but this is not the true for every thing. So here we consider 0 Celsius water. If I consider 0 Celsius ice, so even this is not true. Okay, anyway, so that's the thing about okay. um, okay, and the next question, 22. A particle of mass simple m moves in a simple harmonic motion with angular velocity omega, or angular frequency, and amplitude capital A. What is the kinetic energy of the particle at a over 2? Okay, we know we can write a equation. I think you are very familiar with this equation. V squared is equals to omega squared times a squared minus x squared. Okay, so this gives the speed at of the particle at any position. If you put x equals a, so the speed is 0. Okay, and then when x equals 0, the speed is maximum, that is, which is x equals 0 means it's at the center, so we get v equals a omega, like that. So now we want to find the uh, kinetic energy of the particle at a over 2. So we know kinetic energy is equal half mv squared. So I can write half m times v squared is, we know, I can use this equation. So v squared is equal omega squared a squared minus x squared. So x is equal a over 2, so a over 2 squared. So let's simplify this equation. So we get 1 over 2 m omega squared times, so a squared minus a squared over 4. So if you take this common denominator, so here 4, so 4a minus a squared, 3a squared over 4. So we get 1 over 2 m omega squared times 3a squared over 4. So we get 3 over 8 m omega squared a squared. So answer is third one. Okay, 23rd one. What is the corresponding electric field intensity against the distance graph for the given graph of electric potential versus distance? So here the variation of potential versus distance in a region is given. So we want to plot the corresponding electric field intensity. So we know electric field intensity with the potential, the relationship we know, E is minus delta V over delta D, where this is the potential gradient. Okay, so here we have constant potential, that means gradient is 0. Okay, this gradient is 0, therefore electric field intensity is 0. So from if we use that fact, so it's simply we can see, so either second or 5. Okay, it's becomes more easy now. And then now we have here the positive gradient. Okay, so positive gradient here, so the gradient is positive, therefore electric field intensity is, this is positive times minus negative. The electric field intensity is negative in this part, so the answer here is negative, so this one. And here you can see the gradient is small and negative, therefore electric field has less and positive value, so the answer is second one. It's very easy question. Okay, and 24th one, the change in temperature of 2 mole of gas is 1 Celsius. What is the change in internal energy of the gas nearly? Okay, so here we can write the change in internality delta U is equals to 3 over 2 nr delta T. So delta U, the change in internal energy that we want to find, 3 over 2 times 2 moles, so 2 times R, 8.31 kilojoule per mole, joule per mole. Okay, and delta T is 1. Okay, so 2 cancels off, so delta U is equals 3 times 8.31. So 3 times 8.31 is 8 into 3, 24.3 into 3 is 9. So we get here somewhere around 24.9 something. So the answer is 25. So we want to find nearly. So it's 25 joule. Okay, these are very easy question. Okay, and yeah, 25th. A and B, two identical particles, are attached to a light inelastic string as shown in the figure. End of a string is attached to a fixed point O and the system is free to rotate about the axis through O. The rotation kinetic energy of the system is E about the axis O. What is the new kinetic energy E1 of the system if the masses of the particles are doubled? Okay, so first let's find out E in terms of M and R. So yeah, here I take the mass is M. E of mass is two identical particles, so both mass are same mass. Okay, so I can find out E. E is equals to rotational kinetic energy. I can write half I1 omega squared plus half I2 omega squared. Okay, where I1 is moment of inertia of this mass and I2 is moment of inertia of this mass. Okay, so let's simplify this. So I get E is equal half times I of this is mr squared, mr squared omega squared plus half I2 is m times, now distance to r, 2r squared omega squared. So here this is E, and now it says the masses are doubled. Okay, so if the masses are doubled, now I can write new E1 is equals to half I1, let's take I1 dash, because if the mass changes, the I1 also changes, omega squared plus half I2 dash omega squared. Okay, so E1 is equal half I1 is mr squared. Now mass is 2m, so 2m r squared omega squared plus half I2 dash is now I2 also mass double, so 2m times 2r squared omega squared. Okay, so if I take this E1, so here I take 2 from each term, so if I take this 2 out, I get half m r squared omega squared plus half m 2r squared omega squared. If you want, you can simplify this further. That means you can add these two terms together, and here also you can add these two terms together. But now I can see, but we want to save the time in paper, so here we have this term is equal to this term, so I can write E1 is equal twice E. So the answer is the second one. Okay. Well, here I discuss question number 1 to 25, and inshallah in the next video I will discuss 26 to 50. Okay, until then, take care. Fi amallah.